is pure honesty from my side. So I care about students' feedback, but I just don't want to work very hard on involving myself in these midterm evaluations. And this is because simply that I have so much work to do, and I want to focus on making exercises, making content, on lectures, and not so much of this administrative stuff. So, I don't know who is in charge of these midterm evaluations, but the class representatives in this class, you need to take responsibility for this. For the students that go on, so in the program Digital Business, you have been given some kind of form that has been posted online. And so, at least for that group of students, I think the midterm evaluations is going as it should be. So I recommend that all the students in that program, that you fill in the form that has been posted online. For the students in other programs, I don't know what you have planned, but this is up to you to organize this midterm evaluation. And usually I have a meeting with the class representatives about the midterm evaluation and the outcome of it. And if you want to have such a meeting, I'm available. So that's no problem. But I'm sort of expecting that the students, they take charge of this. So that's what I'm trying to say. Because I want to take charge of other stuff. Okay, then there is another announcement here. And maybe I said it before, and then I forgot. And then they didn't follow up on this. But now, next time, this calculator here, I will give a brief introduction how to use this calculator for the exam and how to solve problems. And this is the HP Hewlett & Packard 10B2 Plus. And this is the only advanced type of calculator you are allowed to use on the exam. So I recommend that you have this calculator. I will show you how you can solve a few things on this, not a lot, but a few things. So this calculator can compute probabilities very easily. So it's really good for that. So next week I'm going to review some of the assignments in assignments 5A and assignments 5B using the calculator. Is that a deal? Why is there not so many students in this class now than when we started? I wonder. Okay, but so do this, because then I think that I can help you a little bit on the exam. So providing you with a little bit of tips and insight how to solve different problems, at least when it comes to finding probabilities for normal distribution and for t-distribution. I think that will be useful for you. Okay, so today's topic, I think it's the most important topic in this class. We're going to start on hypothesis testing. And hypothesis testing is this thing, this is like this shiny thing up in the sky that you look at and say, wow. Because hypothesis testing is how that we can study real-world phenomena and make conclusions about these phenomena. This is hypothesis testing. Analyzing data, compute different stuff, and then make conclusions based on your computations. And then you write a report maybe. You present your results for other people. And this is what is used in what we call empirical research. Empirical research. And when I say research, I mean it in a very broad sense. That means that, okay, you have people in academia, they do a lot of empirical research. But there are also people in other areas of society that do research. So you have all these agencies that provide, maybe they perform surveys, collect data. They also do research. The media do a lot of research. And It could also be companies. Many companies, they do research, they do analysis, or maybe things to do with customers, for instance. So a customer survey, for instance. So when I say research here, I mean in a very broad sense, and hypothesis testing is a major thing in research. And if you want to stand out from the crowd, when you apply a job, then you need to tell them, I know how to perform surveys, I know how to deal with data, I know how to compute stuff. This is a lot of companies that are asking for that kind of skills these days. So maybe I said this before, I don't know, maybe I said it to another class, but I was watching this. So there's a very big bank in all of the Nordic countries, it's called Nordea, maybe you've seen it. That bank is huge. I worked there once. And there was this person in this Norwegian newspaper, he asked management at Nordea what kind of people they were looking for when they hired people. And this is very interesting to know when you are at a business school. And then he said that, okay, so before, we were very interested in people that studied finance, or studied economics, or studied something related. But these days, we are looking for people with technical skills. We are looking for people with technical skills that understands economics and finance just by, maybe they're taking a few courses, or they just have a little bit of insight. So things are moving in that direction. People with programming skills, people with analytical skills, people who can do math. So I worked in an insurance company some years ago. They were looking for people in physics because they know that people in physics, they can compute stuff, they can program, they can analyze, they can work with data. And this hypothesis testing is some part of this. So when you do insurance, you're very interested in computing the risk of some event. So if you have a car, for instance, you need a car insurance. How much should that car insurance cost? So if I look at you or some other person, what is the risk of providing car insurance for that person? And then they look at different things. They look at your age, they look at your dress, they look what kind of car you're going to drive. They look at many things. Do you park on the street? Do you have a garage? Many things that impact the risk of some kind of accident that cost money. And companies are looking for people who can analyze such questions and provide answers for such questions. Hypothesis testing is sort of where we are getting closer to these things. Because we want to analyze data and we want to make conclusions based on the data. So the good thing here is that it's not so difficult to perform a hypothesis test. If you know everything we have done so far, then hypothesis testing is a walk in the park. And everything we have done so far is leading up to this. So we have like a lot of loose ends, and now we're tying up all of these loose ends into one topic. It's called hypothesis testing. So let me just start here a brief introduction. And before we start to compute stuff, let me just, so that there are many ways to motivate hypothesis testing. The way I do it is that I use this here called the rare event rule for inferential statistics. It's so complicated, I cannot even read it, I cannot even pronounce it. This is how complicated. Rare event rule for inferential statistics. So, it's something to do with rare events, something that doesn't happen so often. So let us see what that rule says. It says here, if under a given assumption, the probability of a particular observed event is small or extremely small, we conclude that the assumption is not correct. So what we're going to do is that we're going to formulate some kind of assumption, and then under this assumption, we're going to compute some numbers. And we're going to compute a probability. And if that probability is very low, then we reject that assumption. So the computation we will do is under this assumption. So we set up this assumption and then we say that, okay, let us compute what happens if this is the case. And if the probability is low, then maybe the assumption is not correct. And I will start with this example here. Some of you students, I know that some of you looked at this already. So there are still a few students left in the exercise session. So, and here, this is example 6. So it's not a perfect example, but it's pretty good for what we want to do. And here it says, achievement scores of a high school, achievement scores of all high school seniors in the state have mean 60 and variance 64. So imagine, so like, now this is taken from the US, so there's a state, and in a state there are many high schools. And then you look at their achievement scores, you look at all the students in these high schools, and you look at their achievement scores, and maybe you compute an average. That average is equal to 60, so this is like a population average. So the state is the population in this case. We also find that the variance is 64. Okay, now we're going to zoom in on this state. And in this state somewhere, there is a particular high school we're interested in. So one specific high school among many. And we zoom in on this high school, and it says here a random sample of n equals 100 students from a large high school. So we're zooming in on this particular high school. And then we're looking at a random sample of 100 students from that high school. And then we are going to compute the mean achievement score, and we find that this value is 58. So, look at this number, 58. How does this compare to when we look at all high schools? Then we see that this number is a little bit smaller. So the achievement scores for that particular high school, the mean achievement score is, or the average we find in that sample, is a little bit smaller than it is when we look at all the high schools. It's actually only, it's 2 points below. I don't know if this is big or if this is a big difference or a small difference, but it's below. And now we sort of ask the question, is this high school performing below the state level? So we see here, it's 58. The number here is below 60. So if you're not so trained with this, you will just jump to the conclusion and say, yeah, they're performing below because they have a lower average. But if you're a little bit more trained, then you understand that these 58 is based on a random sample. It's a random process that gives you this number of 58. It could be, by chance, that you got 58. If you ask another 100 students, maybe you get 62. It could be by chance. And this is what you want to rule out, that chance, when you do the hypothesis testing. You're going to implement some kind of framework so that you can conclude, taking into consideration that uncertainty associated with the 58 that you found from the sample. It's a random sample, the 58 you get is a random number. When we look at this mean for the entire state, it's 60. There's no randomness here because it includes everyone. Okay, it says here, let mu be the true but unknown mean achievement score belonging to the high school in question. So this is the high school here from where we collected the random sample. So we let mu be the true mean score for all the students in that high school. That number is unknown to us. If we have a good estimator, then the 58, maybe it's very close. We can hope that this average we computed is very close to the true mean score. Okay, so what we're going to do now, we're going to make this assumption that the variance is the same for this high school that we're looking at. And then it's the same as when we look at all the high schools together. So we will we will take this variance here and apply this variance like this is the true variance for the high school we're looking at. So this is sort of an unrealistic assumption, and later on we will get rid of this. Okay, so let's have a look at this problem here. So example 6. So example 6. Okay, so let x be the achievement score. What should I say? Okay, I just write like this. I could write a little bit more. Okay, so we're looking at this particular high school here. So we did X be the achievement score. And let mu be the mean. So this is the true mean, the true but unknown mean. True but unknown. I don't know, can you see this? It's a little bit polygonal. Be the mean, true but unknown, of the same high school. A little bit more. There. So X here, this is just sort of the achievement scores that belongs to this high school we're looking at. Okay, now we're going to make an assumption. So assumption. And this is the assumption I'm talking about. This assumption is that mu, so remember this is the mean for the high school we're looking at. And now I'm making this assumption that this mu is the same as for the entire state. The entire state had a 60, a mean of 60. So I'm going to say mu is equal to 60. This is my assumption. So the idea here is that I'm looking at this high school, and now I'm going to say, okay, let's say that this high school performs the same as all the high schools in the entire state, academically, in terms of achievement scores. And then I say that this mean is equal to 60. It's the same. There's no difference. So what we're going to do now, we are going to compute what is the probability of getting 58 on average, or less than 58, if this is actually the true mean. What is that probability? So, and in order to do this, we have here, so we have the average equals to 58. So this is from the sample. The number of, let us see here, we have here the sigma. We are going to use the same variance for all the high schools. So this will be the true sigma, and this is equal to the square root of 64, which is 8. And then we have 100 students in our sample. So n is equal to 100. Okay, look at this here. This is the way we standardize. So So we have our estimator here, and I subtract mu, and then I divide it by the standard error. Sigma divided by the square root of n. That gives me a standard normal random variable. So we're going to standardize. So now let us find the probability. So let us find the probability that we get 58 on average or less than 58. So, and that probability is minus 60. So this is my mu. Under the assumption there we go. This here is my mu under the assumption. Remember the assumption here. I just wrote it up again. Assumption. Mu equals 60. So we're going to compute this probability here based on this assumption. And then we have 8, and then we have square root of 100. So now I have standardized. I'm used this expression here. And we do this so that we can find that probability. So we are interested in what is the probability that the mean achievement score for this high school is below or equal to 58. So we have 58 minus 60 divided by 8 divided by square root of 100. There. So this is the probability. And so this here is equal to Z. And remember, Z is a standard normal. Standard normal. Standard normal. And this here is a number. I don't know what it is. Maybe we can compute it. So minus 2 divided by 8 divided by square root of 100. Minus 2.5. Such a pretty number. Okay, so let us just review just a little bit. So what did I say here now? I made the assumption that this high school that I'm looking at performs on the same level as all other high schools. The mean for that high school is equal to 60 under that assumption. However, I found, based on my sample, I found the value 58. That is below 60. Now I'm going to compute the probability of getting these 58. Remember, this is come from a random process. Next time you collect data, you get 61, 62. Next time you collect data, you get 55. Who knows? So I'm going to compute the probability that getting 58 or something less than 58, given mu is equal to 60. And so we get here the probability set is equal to minus 2.5. And for this, since I haven't shown you the calculator yet, I will use the table. There's the table. I was thinking about football yesterday. Do you watch Norwegian football? I watched it yesterday, really cool. We can talk about this in the break if you want. Okay, look at this. Here we have the table. My set score is 2.5, so it's this row here. Here, and here I have the second decimal there. So It's this number there. 0.0062. If we go for 4 decimals, that's what we find. So 0.0062. So what did we find here? We found that the probability of getting 58 or less on average from the sample is 0.0062 if the true mean is 60. We find it's very unlikely that you get 58 or something less. It's very unlikely. So I reject the assumption that mu is equal to 60. I conclude that this high school is performing below 60. This is no coincidence that this number is below. It's because this high school is performing below the state limit. This? Yeah. So I have computed here that the probability of getting 58 or less, given that mu is actually 60. And I find that this is very unlikely. This result you get there is very unlikely if mu is 60. So what we're going to conclude is that we don't believe in this assumption. So we conclude that this high school that we're looking at is performed below the state level. So that is the conclusion. So, conclusion. The high school is academically performing below the state level. There. Okay, so what you saw here now, this is hypothesis testing in action. If you can understand this example, then you understand hypothesis testing. So now I'm going to present you a framework. So if you're uncomfortable with what we did now, maybe you can apply, let's say, a ready-made framework where you simply just put numbers into some kind of an order process, and then you make your conclusion. So let us look at this. So, and this is what you need to do for the exam. You need to apply this framework. I'm going to present to you now. Okay, so we start with the hypothesis. So when you do a hypothesis test, what you do is that you formulate what's called a null hypothesis and an alternative hypothesis. The null hypothesis, we use the letter here H0, H0, and for the alternative we use HA. I use HA. So you can also somebody use H1. The null hypothesis, that is the assumption. So this is where we start. So the null hypothesis is typically a hypothesis of status quo. Statements such as no effect or no difference are common. So it will sort of be the hypothesis if you don't know anything. The alternative hypothesis is stated as a hypothetical claim. It contradicts the null hypothesis. So the alternative cannot be true at the same time. So these hypotheses, they are exclusive. So it cannot be that both the null hypothesis and the alternative hypothesis, that they are true at the same time. That cannot happen. If one hypothesis is true, the other one is false. We will see some examples just in a second. It says here, when performing a hypothesis test, we are looking for evidence against the null. So we are looking in the data to see if we can find evidence against the null hypothesis. That will support the hypothetical claim under the alternative. So here in this in this text, this is a test for the mean. A test for the mean. There are many different hypothesis tests. So we start with a test for the mean. There are 3 different ways to formulate the alternative hypothesis, depending on what you want to know. What is the phenomena you want to analyze? So we have what's called the one-tailed hypothesis. So here we have mu larger than some number, mu naught or mu 0. This is just a number. This is a number that you put in there. You would know this number from before. So here the first formulation of a one-tailed hypothesis is that mu is larger than some number. The null is just that mu is equal to that. Depending on the question, the phenomena that you're analyzing, you may also want to formulate mu is smaller than some number. It depends. So these are the 2 ways to formulate the one-tailed hypothesis. Then we have the two-tailed hypothesis. That is, mu is different from some number. Different from some number. I like the one-tailed type because it makes a lot of sense, mostly. But sometimes we do the two-tailed also. When you do a test, you would make some errors. So in the long run, you will make errors. So we have what is called type 1 error, and we have what's called type 2 error. And the type 1 error occurs if the null hypothesis is rejected when it is true. Okay, so you have a true null hypothesis, but then by mistake you reject it. Then you have made a type 1 error. The type 1 error is a very bad error. That is something that you don't want. I don't know if you, so here is this is the usual explanation for type 1 error. Imagine that the police, they have a suspect. Somebody did some criminal activity, and now the police have a suspect. So, the null hypothesis in most good societies is that this individual, so the individual that the police suspect did some criminal activity, the null hypothesis is that this individual is innocent. So that is the null hypothesis. If we don't know anything, we will just assume that this individual is innocent. Then it's up to the police to investigate and find evidence that this person actually did some criminal activity. And if this evidence is strong, we can put that person in prison. The type 1 error in this case would be to put an innocent person in prison. This is a very serious mistake. We rather let a guilty person go than putting an innocent person in prison. If there's any doubt, we just let this person go. So we need strong evidence before we put a person in prison. And the reason why we want the strong evidence is because we don't want to make the type 1 error. Then we have the type 2 error. It occurs if a false null hypothesis is not rejected. That is not such a big problem. It's like if you have a person that is guilty, but you don't put that person in jail or prison. That is not such a big deal, seen from the perspective of society. So this is the type 2 error. So when we do a hypothesis test, we can control the type 1 error. And this is called the significance level alpha. You choose this before you do the test. It's a choice you make. The type 1 error that you can allow for is alpha. And alpha can be 0.01. So that means in 1% of the cases, you are allowed to reject a true null hypothesis. If you choose alpha equals to 0.05, you allow, in the long run, to reject a true null hypothesis in 5% of the cases. So if you perform 100 hypothesis tests, then in 5 times you will reject the true null hypothesis. And then sometimes we use alpha equals to 0.10. So then we allow for 10% rejection of the true null hypothesis. In most cases, you just use 0.05. So this is like a convention. Okay, the one sample set test for the population mean, when the standard deviation is known, the true standard deviation is known sigma. So the way that we do this hypothesis test is that we choose one of these formulations here, and then we compute what is called the realized test statistic, and it's computed with this formula here. And here mu0 is the value of mu under the null. And then we're going to compute what is called the p-value. And here you have the p-value. It says that the p-value of a test is the probability of obtaining a test statistic as extreme or more extreme as the one realized from the sample, given a true null hypothesis. This is a little bit difficult, this one here, but we have already computed the p-value. So in this case, we found that this is the p-value. The decision rule is that you reject the null hypothesis when the p-value is below the significance level. That is the rule. This rule here, this is written in stone. That means that it always applies, no matter what. No matter what hypothesis testing you're doing in this world, it's the same rule. Like this. Okay, so let us go back to that problem. Let us go back to example 6, and let us apply the framework I just showed you. So we go back to example 6. We should just continue. So, our concern is that this high school we're looking at, it performs below the state level. That is our concern. So usually what you do is that you formulate the alternative hypothesis first. So now the hypothesis formulation of the null and the alternative. So I start with the alternative. So imagine that you are maybe on the board of the school, or you are the director of the school, the principal. You are concerned with the student's performance. So the alternative is that mu is less than 60. You don't want your students to perform below the state level. So you could write here, this is poor performance. And your null hypothesis, that is that mu is equal to 60. So this is, the school performs at the same level. So this is how we formulate this. The realized test statistic this is my set. It's a number, it's a small set because it's a number. And it's the average minus mu naught sigma divided by n. You standardize that number. So in our case here, we have, just to summarize a little bit, we have this 158, sigma equals 8, n equals 100. So those are the numbers we have. I plug in the numbers, 58 minus 60. So this is the value of mu under the null, divided by 8, divided by 100. And the number you get, that number is minus 2.5. Okay, we are going to find the probability of getting 58 or less. And that is the p-value in this case. So look at this table here. This table here, it tells you how to compute the p-value. You see, okay, if I have an alternative hypothesis of this form here, then the p-value is given by this expression here. So let us use this. So the p-value. So we're going to use this here. P-value equals the probability that's set. This is standard normal. Normal, random, variable. And this is less or equal to small, the lowercase z. And this is the number that you computed from the sample. And then it says, given the null hypothesis, and this is based on this assumption we had, that mu is equal to 60 in this case. So when you put in the 60 here in the computation, you took care of this condition here. So this is just, what do you call it, semantics. It's a mathematical language. So this is already taken care of. So the only thing you need to do is to write this, set smaller equal to minus 2.5. Like this. And surprise, surprise, this probability is 0.0062. I just need 1 minute more before the break. Then we're there. If you understand what I'm doing now, you understand hypothesis testing. Then you can do this. Big part of the exam. Okay, so let alpha equals 0.05. Sometimes we write 5%. The conclusion is then and here I'm going to give you a recipe for how to write the conclusion on the exam. This is a recipe. Just follow this. So in real life, we will write a little bit longer. We will make a report about the results. Here is the very, very short version. Since the p-value equals to 0.0062 is less than the significance level. Something like this, which is equal to 0.05. The null hypothesis. I don't think there is this here. It's just null hypothesis. Is rejected. This is the technical part of the conclusion. The technical part. Now comes the verbal part. And I wrote it up beforehand. And I need my glasses because I'm almost blind. So, here is the verbal conclusion. Thus, the result of the test supports, notice this word support. We have support for the alternative hypothesis. So this is an A, alternative. That the high school in question performs below the state level. There were some words there. Can you read what I wrote here? Are you okay with this? Should I read it up? It says here. Wait, we're not done. So, this is the technical part. This is where you make your choice if you reject or not. This here is the insight from the analysis. Never forget this. I emphasize this a lot because we are not doing this for fun. We're doing this because we want to acquire knowledge. And it says, the result of the test supports the alternative hypothesis that the high school in question performs below the state level. So, this is the insight. If you're making a report, maybe you write 2 pages about this. Maybe more about the consequences, maybe more about this and that. I don't know. I'm not the researcher here. So, I expect that you can do this and you can do this on the exam, and if you skip this part, I will just deduct a few points there. Understand? So, because there's no point of doing statistics if you don't apply it and gain knowledge from it. This is so much work to collect the data and all of this, and then you just reject or not reject. Is that it? I want a little bit more. Okay. We take a break, and we come back here 5 minutes